We will show you proof of work now. So each node is going to start trying to mine the first block, and they will, try to do it until they get the correct hash. So you could see that node in the lower left just was the first one to mine the block, and sent it to everybody else. And now we already had that node in, I think, top right, mined block number 2, and sent that block to everyone else. You can see that it sent the block messages. Another thing you can notice is that when the nodes output the starting state for the next block, they all have the same starting state. So everyone has the same starting state for block 3, because every node is getting the blocks and keeping track of the blockchain, and it's all consistent among the nodes. We have a coin base of 100 for this proof of work. So every time a node mines a block, it gets another 100 coins. So that's where some of the other amounts are coming from. And as we can see, if all the states are still consistent, at this point, we just need to wait for somebody to make a bad one with double spending. Okay, so now we can see that nodes are verifying blocks before they add them. So you can see those 3 nodes all rejected this new block 10 because it had double spending. If you look at the node in the lower right, you can actually see, so that node mined a block where Xu Ying sent 63 coins to everybody else. But you can see from the starting state of block 10 that she did not actually have that much money. So even though this node generated and mined that block, all the other nodes rejected it. And now they will just wait for the next person to make a valid block 10 that will then get sent out. Okay, cool. Yep. So now we can see somebody else. Well, actually, it looks like another person made an invalid block 10, but then I think that node in the lower left figured out a valid block 10 and sent it to everybody. There you can see here, just to demonstrate real quick, that this node is writing the blockchain out to the file as it gets new blocks. You can see it has all the information there, the hashes, the number, the nonce, the coin base for who mined the block, and then also the list of transactions. So for our proof of stake algorithm, all the nodes are running kind of a version of Raft. Basically, there's a period of time where we create a block. I think it's like every 15 seconds. So every 15 seconds, the nodes will elect a new leader. That leader will create a block, and then it will send that out to the other nodes for verification. So there's also a chance that someone will decline to start an election because they made too many blocks. So here, this node had already made the only block in the chain, and we have it set up so that no node can make more than 40%. So here you can see that one declined to try to be a leader itself because it had already made too many blocks in the chain. There is also, they only have a 40% chance of holding the election, even if they are eligible. Okay, yeah, so you can see this node in that case declined to try to become the leader just because its random value was off. It only has a 40% chance. What else? So after a leader generates a block, like I said, it gets verified and signed by everyone else and then sent out to all the other nodes, so that all the other nodes have a consistent view of the blockchain. Finally, no node will verify a block if it has double spending. So there we can see a very clear example where 2 nodes had made too many blocks and some nodes had not the right random values. So everybody decided to not start an election, but then eventually that node in the bottom left did. Just had an instance where somebody made a bad block. Okay, so the Xu Ying node made this block 9, but all the verifiers rejected it. because so here we can see that this node made a block that ended up nobody verified it because it was bad. Just looking at the transactions, we can quickly see that Umer was trying to spend more money than he had. So when this leader made that block and sent it to the rest of the nodes, they all refused to verify it, and hence you can see like the message in that node in the bottom left, where it said that block was not valid because of double spending. And then so after that, somebody else went on to make a new block 9 that was valid instead. Here, this is the file output for the blockchain of this node. So now we are looking at one of the files written to disk by one of the nodes. We have it loaded into a JSON viewer just to make it easier to read, because that's the format we were writing the data out in. And when we look at this, we can see a couple things. One is that the blocks get signed with sufficient proof of stake, which means they get signed with enough stake to cover all the transactions. So if we look at block number 1, which is at the bottom, it doesn't really matter because that's the first block. There's no transactions. But there's a part of it called the stake person, which also has a stake amount. And that is basically the reward that the leader or creator will get once this block has been verified. We can also see, I should point out, that we have our list of verifiers, which has a node name, and then also the signature that node created with its private key. And then the final signature is created by the leader or the node that created the block. It is also signed with the leader's private key. And as the nodes exchange these blocks, they make sure that the signatures on like the verifier or the final signature, they make sure that those decrypt properly using the public key of the relevant node. So as the nodes pass the blocks around, that's all double checked. So now let's look at block number 2, which has a reward of 22. Can you open the transactions? Okay, yeah, so this block had 2 transactions of 40 each, so a total of 80. Can you open the stake person part of that one? Yeah, okay, and so here we have the node Hattie created this block and staked 40. And then that reward of 22, that's the amount that all the verifiers will get once they have once the block is verified and we move on to the next block and we're calculating how much money everyone has available. So there's kind of 2 different stakes. There's the stake from the stake person, which is how much the creator put up. And then there's this reward element, which is how much the verifiers will get for verifying the block. For this particular block, we can see that the stake person put up 40. The verifiers will each get 22 coins. So that makes 66 total. Stake for the verifiers plus 40 for the stake person is 106, which is greater than the 80 of the transactions in the block. And if we look at block number 3, we should see the same thing. So can you open the transactions? So it had 2 transactions for a total of 52. So the stake person put up 26 stake for that. And then this block had a reward of 15 for each of the verifiers. So 3 verifiers times 15, we get 45, plus 26 is 71, greater than the amount of the transactions in the block. So the block was appropriately signed with sufficient proof of stake before it was verified. And as I mentioned, as we make more blocks, the verifier's account is getting the reward. So we can see, can you go back to the first block? So in this one, Xu Ying would have got 100, and then all the other nodes would have got 52. And then when we move on to block 2, we have Xu Ying sending a total of 80 in the transactions, and that's okay because that node had 100 to begin with. So it had enough money. And then if we look at node number three, or sorry, block number three, we have the Hattie node sending a total of 52, which is fine because that node would have received, let's see, 40 because it was the creator of block number two, and that was its stake amount. Plus, how much did it get from block one? Plus 52 as a reward from block one because Hattie was one of the verifiers on that. So by the time we get to block three, Hattie has 52 plus 40 is 92, which is enough to cover the 52 that node is sending to the others. The last thing we wanted to show you was just that all the nodes end up with the same blockchain. They reach consensus. So here we're looking at the output files of each node on the disk showing its blockchain. And we have the entry for block number two highlighted just to make it a little bit easier to see as an example. But yeah, we can see that everybody has the same block number two in this file with the same transactions where the node Uber is sending 20 to everybody. They all have the same verifiers of Xuying, Ben, and Uber. I'm not going to get into the hashes, but the hashes also match. So yeah, just to demonstrate that all the nodes reach consensus on the same blockchain and they all see the same thing. So with that, I think we've shown all the parts of proof of stake. Thank you for watching.